This is 3.2, day 1, part 2. So now we're going to use those properties on the previous slide to solve for x. So first example, a logarithm of base 4 of 1 equals x. And we want to find out, what does x equal? So we're referring to these properties. What property does this go with of these 4? The first one, a logarithm of base a of 1 equals 0. Is that true here? So what should x equal? X should equal 0. Why? I'll just show it to you. If I rewrite it in exponential form, 4 to the x equals 1. What must x equal to get it to be 1? 0. So that's why. Question B. A logarithm of base 5 of 5 equals x. What does x equal? 1. Do you want to understand why? No. Yeah? No? If we rewrite it into exponential, 5 raised to the x equals 5. What must x equal? 1. Because if I throw a 1 power over on the right, the bases are the same, then that means the exponents must be the same. Okay, let's get on to question C. Logarithm of base 9 of 9 to the 4th power equals x. Yep. So what I remember is I just think of these as if I have a logarithm of base 9 and an exponential of base 9, is they cancel each other out, the inverse property. So you're just left with whatever that exponent is. Question D. What property does that go with?
1.
The 1 to 1. I have a logarithm of base 7, and I have another logarithm of base 7 on the right. So the 1 to 1 property says then these two pieces must equal each other. So what does x equal then? 9. Okay. E and F, we've already kind of done. I want to go down to question G. And this will be our last one we'll do. What property do I do to solve this one for x? Question G.
1 to 1.
1 to 1. I have a logarithm of base 4 on each side. So I set these two equal to each other. Am I done? No, now I have to solve it for x. So I subtract 1, and I get x to be 7. Substitute 7 back in to this place. 7 plus 1 is 8. A logarithm base 4 of 8 equals a logarithm base 4 of 8. Now we're moving into natural log. Natural log is when you have a logarithm of base e. This is the only other logarithm that you can use your calculators for to evaluate. The common log and the natural log. Common log was a base 10. Natural log is a base e. And we learned about what base e is approximately. What is e approximately? 2.71. So kind of think of it as pi. Pi, we drop it to 3.14. It's a number that we can't get specifically down, so we approximate it to 2.71, but it has a fancy letter E to represent it. So if I have an equation, a logarithm of base E of x, more commonly we use this notation. This is what it refers to, but we call it the natural log, ln of x. So be comfortable with both forms, though. Be comfortable with this blue form or the red form when you're doing your assignments, when you're taking your quizzes and tests. So we're going to do the same thing like we did with the common log problems. We're going to take out our calculators and evaluate it for these situations. So the natural log of 2. What is the natural log of 2 with our calculator? 0.69. If I rewrite it to exponential form to understand it, you don't have to. What this is saying is it's a logarithm of base E of 2 equals 0.69. How would I rewrite that in exponential form? What's the base? 10? What's the base? E. What's the exponent? 0.69 is approximately 2. Okay, let's go to the next one. The natural log of 5/8. I recommend you throw parentheses around 5/8. The natural log of 5/8. What is it? Negative 0.37. 47? Negative 0.47? Okay. And then we can rewrite it to exponential if we wanted to understand it. Last one. Enter in the natural log of -1. Error, or does not exist. Tomorrow, when we get into graphing logarithms, you're going to understand more why this is true in your calculator. It's to do with the domain. There's domain restrictions on logarithms. So we'll get into that tomorrow. Okay, properties again occur with the natural logs. They're essentially the same 4 properties that you had on this slide. So these 4 properties are the same 4 properties for natural log. So if you want to maybe just off to the side, or write them down. So property 1 of the natural log. The natural log of 1 equals 0. And I'll just explain why in exponential form. In exponential form, it's saying a logarithm of base E. So my base is E. My power or exponent is 0 equals 1. So anything raised to the 0 power we know is 1. So e to the 0 power is 1. Property 2. A logarithm of base E of E equals 1. Why? An exponential equation, base E raised to the 1 equals E. And then the inverse properties are also true. And then 1 to 1 should look pretty similar too. And then I just have a few practice problems again, like what we did after the properties of the common logs, the logarithms.